Hey everybody, we're going to finish up with our transformations today, talking about our last parent function. Today we're going to look at and see how A, C, and D affect our rational parent function. Remember, right here's our rational parent function. One of you turned me onto the idea of ratio being part of the word, and the actual function is a ratio. So it's a really good way to remember it if you didn't know that already. It was kind of news to me. Pretty awesome. Anyway. So you guys remember the rational parent function looks like this guy right here. It's the one that's broken into two pieces because it has those asymptotes that run through the middle of it. If you recall from when we talked about exponentials, asymptotes are those invisible lines that the graph gets really, really close to but never actually touches it. So remember my picture here on the screen, it looks like the curve, the black curve, gets really close and touches the x and the y axis, but it really, really doesn't. It's just so close that our human eye can't see the space between the graph and the axis. It's never, ever going to touch them. If that's the case, then it affects our domain and our range just a little bit. The cool thing about this is that if you look at it, if I put arrows on this, I would see that this rational function goes to the left and the right and up and down forever and ever. That makes it really easy to do domain and range, because that just means that it's all real numbers, right? It's everything, because it never stops in every direction. The only thing we have to account for are those red asymptotes running right through the middle. If I'm talking domain, then what I need to look at is all of the x values, or watch the function rather as it comes across the x-axis. As it gets really, really close to 0, notice how this black function never actually touches the 0. It gets really close, but once it does, it has to turn off down here towards the bottom because it can't touch it. I have to make sure I tell the reader that the domain is all real numbers except for 0. Remember that sign in the middle says not equal to. Same thing for the range. If I follow this, this function in the y direction, I'm coming down the y-axis and down the y-axis, but as I get closer to 0, I can't touch it, so it forces my curve to run off to the right. So y cannot be 0, but it can be everything else because it goes forever and ever. So right here I've got a definition for you. An asymptote is just a line that the curve approaches but never actually intersects. Remember, that just means touches or runs into it. So you guys saw this last week on your cheat sheet that I made up for you. This is just the rational function when we are adding the extra pieces in, those parameters of A, C, and D. Cool thing about this is they're just like all the rest of the functions. This one right here is our vertical stretch and compress. C down here is my horizontal shift. And the one over here, D, I bet you can guess, is the vertical shift. The sign out front is does the same thing as it did on all the rest of our functions. It's going to reflect it across the x-axis if it's negative. Okay, it's going to reflect it if it's negative. That just means turn it over the x-axis. So check out this example we've got going down here. You see that this function right here is the one that's graphed. It's a lot of junk going on right here, but you can see right there, and again over here, that's where it's actually graphed. The key on this is we talked about with our parabolas is the vertex that shifts, and when we did absolute value, it's the point where the two lines meet to form the V. That's the point that shifts. On our exponentials, it was the asymptote in the one critical point that shifted. For these guys, it's the asymptotes that are going to be really important. That's the part that's going to move around. You have to get those established first. Then you can draw the graph on either side of them, depending on whether or not it was reflected. So you have to remember way back from Algebra 1, equations of lines. Let me show you what I mean. I bet you'll see right here what we've got going is this is our horizontal shift, and it's backwards. So it went to the right too. So you'll see that that vertical asymptote is now running through 2 right there. This is our vertical shift right here at 4. So you'll see the vertical asymptote started at 0, 0, or at the line 0 down here, and it moved up 4. So once you've got those red asymptotes drawn in there, then that's when we go through and actually draw the black curve. To write the equation of the asymptote, remember it's just the axis that it runs through and the number. So x equals 2 is the equation of that red dotted line right there because this line runs through the x-axis at 2. That's all there is to it. Same thing over here. If y equals 4, it's the equation of this red asymptote, the horizontal one right there, because it's running through the y-axis at 4. See right there, y-axis at 4? You're going to need to know that for later here in just a minute when we're actually graphing these equations. So turn your page over, and let's look at one that hasn't been graphed for us yet. I know it's a rational function because the x is on the bottom, it's a ratio. This time let's look and see what all the different pieces are doing. Let's kind of break it down and analyze this equation. If I look at 2, I know that that's A. I know that this guy right here is C, and this one is D. If I label them, it kind of helps me keep track of what's going on. So then it's very easy to decide what goes with what, or what happens to the function. I'm also going to look right out here at the sign in front because that's important as well. I notice at the sign out front that there's not one, so that means it's positive. So it doesn't really do anything. It doesn't affect it. So I can kind of ignore that. A right here is a number greater than 1, so it's a vertical stretch. C right over here, it's a negative 4, so that means that it's a horizontal shift to the right 4 units, and D is a positive 3, so that's a vertical shift, and it goes up 3 units because it's positive. Remember, the only one that is backwards and weird is C. It's the horizontal shift that's always goofy and backwards. Okay, so this is all important because now I can actually graph it on my little my grid right here. So this is important. I'm going to have to deal with this shifting first. Alrighty, so bear in mind that right now these asymptotes are right here. That's where they begin on the parent function. But this information over here tells me that they shift to the right 4 and up 3. So if you can envision picking up this red cross right here and the whole thing and shifting the whole thing right and then up, we're going to set it back down so I can draw my curves. So this vertical one's going to come right 4. 1, 2, 3, 4. And the other one shifts up 3. And I'm going to come back and erase those red ones so it's a little clearer. All right. Now that I've got my new asymptotes in there, that's all the shifting. Now all I have to do is show that it stretches and draw the graph in. That's it. Let's talk about domain and range real quick. Domain, if you recall, it goes in every direction forever. So it goes left and right forever. That means it's all real numbers. The only thing I have to tell the reader is where the one place where the range, or excuse me, where the domain doesn't exist, and that's right here. That's the one x value that it can't be at, because that dotted line says it can't go there. So it can't be 4. The range is similar. Remember, it's all real numbers because it goes up and down forever. But then I tell the reader that, hey, there's that one spot right there. That's the only one it's not going to touch. So y cannot be 3. That's all there is to it. Last one down here, they are telling me to sketch the graph if the rational parent function is moved so that the asymptotes are here and here. So in order to sketch this one, I have to sketch the lines that represent the asymptotes. It's telling me that 1 goes right here, where x is equal to 10. So 1, 2, 3, 4, 5, 10. An asymptote runs right through there. The other one is at y equals 5. It's telling me to touch the y-axis at 5. There was no stretching or flipping or anything else to be done, and so we can sketch this just like normal, except my sketches are terrible. That's it. Excellent. Let's jump on over and investigate inverses real quick. So that's lesson 7. Inverses. Oops, I didn't get your essential question written in there. We'll do that later. But right here, an inverse, here's your definition right here. That's notation for an inverse. Instead of saying f of x for a regular function, we say that little -1 exponent, it represents an inverse. It's just where the domain and the range trade places. Literally, your x and your y are going to swap spots. And that's all there is to it. So look right here. This asks you to find the inverse of this set of data right here, of this function. So in order to do that, I'm just going to swap, trade colors, now I'm going to swap the x and the y. So everything I see over here in the x column, it's now going to be written on the other side. So I'm going to switch these guys. And then switch the next two guys. So this piece right here, that is the inverse of the original table. That's it. Come down here and let's look at it on a graph, in graph form. This is exactly the same because remember a scatter plot is just a graphical representation of a table of values, right? There's a t-chart here. So I'm going to start off by listing out my x's and my y's. So the coordinates at this point are -5, -6. And the coordinates of this point are -3, -5. So now to find the inverse, I'm just going to flip-flop everything. Sometimes you'll see this maybe written like this, x prime and y prime. That means the new function. Okay, we've done something to it, and now this is the new one after we messed with it. So remember, an inverse is just swapping the domain and range. So my new point is like this. Notice how I'm just switching those two numbers around. Once I've got all that information in there, now I'm going to graph those new points. Okay, check it out. So I graphed them real fast for you. One thing I probably ought to point out, look right here. I made a goof. Your notes are going to say something different because you copied something different because that's what I showed you, but I actually graphed that point incorrectly. So make sure you get that point and that inverse written correctly on your notes so that when we graph them, it makes sense. Okay, so basically all we did here is we graphed, we took the black points, switched them around. Now I have red points. You'll notice that the line of reflection is this right here. It just mirrored right across that line, y equals x. Easy cheesy. One more page over here. Now I've got a parabola. This one doesn't have the points specified for you, but you know that every point on that parabola is, well, it's a point, right? Make sure you pick good logical ones. I usually, with a graph that is curvy, suggest about 5 points, but make sure you're picking good ones. That's a good point right there. So over 0 up 2. This point right here that I just graphed, right? Let's see right that one right there. That's not a good point because it's got decimal numbers, so don't choose those. Choose ones that are going to have whole numbers. So, for instance, this would be a good couple of logical points. And maybe a couple in between, like those two. Okay, now we're going to do the inverse again. Once you have the inverse, then you're just going to graph them, and you'll see this parabola reflect over that line, y equals x. Your brain has to remember that this is a parabola because obviously it looks like a V right now. So make sure you've got a little curvature going on the bottom there. Oops, and try to hit the points that you draw. So there's your inverse. Again, you'll notice that it's reflecting across this line right here. It's a mirror. Last one. Again, pick 4 or 5 good points. I think 4 are sufficient here. To get the inverse, you're going to flip them over, trade their places. Oops. And then graph them. When you're doing this, I'm going to recommend that you always, always, always use this method. Even those of us that are very visual, honestly, have a really hard time accurately reflecting these by just looking and graphing. If you try just to make, ooh, that's terrible. If you try just to make a general sketch without putting down a few specific points, I guarantee you're going to get about 60% of them wrong. Especially when we are doing just straight lines, those are extraordinarily difficult to see reflected. So make sure that you're always just taking a few points and flipping them. It doesn't take that long. Just to sum it up down here, inverses just reflect the graph across the line. That one right there, remember? Y equals x. It's just the linear mother function. And that's it.